This video is going to deal about the types of memory, concepts of virtual and cache memory, and address translation in the virtual memory. Let's see the content. Types of virtual memory. A computer memory management unit handles memory operations, which includes managing a virtual memory. In most computers, the memory management unit hardware is integrated into the CPU. There are two ways in which virtual memory is going to get handled. One is going to be paged and one is going to be segmented. What actually the paging is? A paging divides memory into a section or paging files, usually approximately 4 kilobits in size. When a computer uses up its RAM, pages not in use are transferred to the section of the hard drive designated for the virtual memory using a swap file. A swap file is a space set aside on the hardware drive as a virtual memory extensions of the computer RAM. When the swap file is needed, it's sent back to the RAM using a process called as page swapping. So page swapping is nothing but sending back to the RAM. That's going to be called as the process of sending the files to the back to the RAM. That is going to be called as page swapping. This system ensures that the computer's operating system and application do not run out of the real memory. The paging process includes the use of page tables, which translates the virtual address that the operating system and application use into the physical address that the main memory management uses. Entries in the page table indicates whether the page is in the real memory or not. If the operating system or a program does not find what it needs in the RAM, then the memory management unit responds to the missing memory reference with a page fault exception to get the operating system to move the page back to the memory when it is needed. Once the page is there in the RAM, its virtual address appears in the page table. Paging provides a somewhat easier interface for programs in that its operation turns to be more automatic and thus transparent. Each unit of transfer referred to a page is of a fixed size and swapped by the virtual memory manager outside of the program's control. Instead of utilizing a segment or an offset addressing approach as seen, paging uses a linear sequence of virtual address which are mapped to physical memory as necessary. Due to this address approach, a single program may refer to a series of many non-contiguous segments. Although some integral fragmentation may still exist due to the fixed size of the page. The approach virtually eliminates external fragmentation, a technique used by the virtual memory operating system to help ensure that the data you need is available as quickly as possible. The operating system occupies a certain number of pages from your storage device to main memory. When a program needs a page that is not in the main memory, the operating system copies the required page into the memory and copies another page back to the disk. This is going to be called as paging. Next one, segmentation. What is segmentation? Segmentation is also used to manage virtual memory. This approach divides virtual memory into segments of different lengths. Segments not in use in main memory can be moved to virtual memory space on the hard drive. Segmented informations are processed or tracked in a segment table, which shows if the segment is present in the memory or not, whether it has been modified and what its physical address is. In addition, the file system is segmentations are only made up of a list of segments mapped to a processor's potential address space. What actually the paging is going to be? So already we have come across over there. Let's discuss about the difference between paging and segmentation. Segmentation and paging differs as a memory model in terms of how memory is going to be divided. Some virtual memory system combines segmentation and paging. In this case, memories get divided into frames or pages. The segments take up multiple pages, and the virtual address includes both the segment number and the page number. Such a way, this is the difference actually it's going to be between the paging and segmentation. Let's discuss about the concept of cache and virtual memory. A cache memory introduced to bridge the speed gap between the processor and the main memory, and which have been implemented upon the hardware, whereas the virtual memory introduced to bridge the speed between the main memory and the storage, and which is going to be partly implemented with the help of the software. What is an address translation? In a system with virtual memory, the main memory can be viewed as a cache for the disk, which serves as the lower level storage. Due to the enormous difference between the main access time or memory access time and the disk access time, a fully associative cache scheme is going to be used over there. This is the entire main memory is a single set. Any page can be placed anywhere in the main memory. This makes the set field of the address vanish. All that remains are a tag and an offset. So the offset field identifies a particular location within a page or frame. The tag field identifies a page in the local address space. Since the tag field just identifies a page, it is usually called as page number field. Assume that the program and data are composed of fixed length unit called pages. A page consisting of a block of word that occupies contiguous locations in the main memory. A page is a basic unit of the information that is transferred between the secondary memory, secondary storage and the main memory. The size of a page commonly which ranges from 2 kilobytes to 16 kilobytes. A page should not be too small because the access time of the secondary storage is going to be much larger than the main memory. Meanwhile, the pages should not be too large also. Else, a large portion of the page may not be used and it will occupy valuable space in the main memory. Let's see about the logical address. With a virtual memory system, the main memory can be viewed as a local store for a cache level whose lower level is in a disk. Since it is fully associative, there is no need for a set field. So the address just decomposes into an offset field and a page number. So the number of bits in the offset field is determined by the page size. The remaining bits are going to be called as page number. An example, a computer uses 32-bit byte addressing. The computer uses paged virtual memory with 4 kilobytes page. So how we can calculate? Since there are 4 kilobytes in a cache block, the offset field must contain a 12 bits. So 2 to the power of 12 is equal to 4 kilo. So the offset field is going to be having an 12 kilobytes. Then the remaining bits out of 32, 12 are going to be in offset and remaining are going to be 20. So the 20 are going to be there in the page number. So thus a logical address is going to be decomposed as shown in the figure as page number 20 and offset is going to be 12. So each virtual or logical addresses generated by a processor is interpreted as a virtual page number, an higher order bit, plus an offset, a lower order bit that specifies the location of a particular byte within the page. The information about the main memory location of each page is going to be kept in a page table. The main memory address where the page is going to be stored, the current status of the page also going to be present over there. So the area of the main memory that can hold a page is going to be called as page frame. Starting address of the page table is going to be kept in a page table base register. Virtual page number generated by the processor is going to be added to the content of the page table base register. This provides the address of the corresponding entry in the page table. The content of this location in the page table is given the starting address of the page if the page is going to be currently in the main memory.